Okay, for what we have in number 20, okay, we're looking at a first order linear differential equation, and we're looking at solving for y, whereupon we have y prime is equal to 1 plus x plus y plus xy. And we have the initial condition that y naught is equal to 0. And if you notice, you have a couple of first order terms in y. And what I can do is that I can consolidate these. And for what I have in the meantime, so y prime, okay, if I utilize Leibniz's notation, okay, so you have dy over dx is equal to 1 plus x, and putting in terms of a single y, okay, so y plus xy is going to be the quantity of 1 plus x times y, okay. And if I put this equation in terms of first order linear standard format, so I'm just going to take dy over dx minus the quantity of 1 plus x multiplied by y is equal to 1 plus x. Now, we're going to have for p of x, again, that is going to be the negative of the quantity of 1 plus x. And we can just write this as negative 1 minus x. And for the integrating factor, so we have e to the integral of p of x dx. And we have this equal to e raised to the integral, where we have negative 1 minus x quantity dx. And so we will have e to the negative x minus 1/2 of x squared. Again, this is going to be our integrating factor. And we can multiply all the terms in the equation from the standard form by the integrating factor. And I'll just use a little bit of a shortcut. Okay, so I have e to the negative x minus 1/2 of x squared times dy over dx minus the quantity of 1 plus x times y. And we have is equal to times all of 1 plus x. Now for what we have on the left-hand side, and you don't have to worry about distributing, okay, but just keep in mind that the end that has the derivative, once you multiply by the integrating factor, what you're going to have ultimately on the left, regardless of whether you distribute or not, is going to be the product rule expansion of multiplying the integrating factor, again, which we have at e to the negative x minus x squared over 2 times the dependent variable, which we have in y. And again, we have is equal to what we have on the right. Okay, which we have with e to the negative x minus 1/2 of x squared times the quantity of 1 plus x. And we have integrating over both sides. So we have e to the negative x minus x squared over 2 times y. And we have is equal to the integral. Can we have e to the negative x minus 1/2 of x squared times the quantity of 1 plus x dx. And for what I have on the right, I can perform use substitution. So if I just step to the side here, so I have e to the negative x minus 1/2 of x squared times all of 1 plus x dx. And I can set u equal to the degree to which we have e to be raised. And taking the differential on both sides, okay, so I have -1, you have minus 2x over 2, so you have -1 minus x quantity dx, and putting dx in terms of du, and if you notice, if I divide by -1 minus x, we'll have the negative of the quantity of 1 plus x and we have from the u substitution. So we now have the integral of e to the u, and we have times the quantity of 1 plus x. And for dx, again I have du over the negative of the quantity of 1 plus x. And again, be careful with the sign values. Again, so we have 1 plus x to go out, okay, but you have the negative that remains. Okay, so this will come down to the negative of the integral of e to the u du. And for what we have in following through, so you have the negative of e to the u followed by the constant, and we have with the back substitution, so we have negative e raised to the negative x minus 1/2 of x squared followed by the constant. And for what we have on the right hand side, again we have negative e, so negative x minus 1/2 of x squared followed by the constant. And for what we have upon isolating y, okay, so you have negative e to the negative x minus 1/2 of x squared, and if I divide by e to the negative x minus 1/2 of x squared, okay, what's going to happen in this particular case, all right, is that we're going to have adding x and 1/2 of x squared, okay, to this power, and that is going to be -1, and we have plus c times e to the positive x plus 1/2 of x squared, and we have with the initial condition, okay, so you have y naught equals 0, and so we have y is at 0 when x is at 0, so you have 0 is equal to -1 plus c, and so this is going to land c is equal to 1, and so putting back in, so we have for the specific solution, then we have that y is equal to -1 plus e raised to the x plus 1/2 of x squared. Okay, for number 36, okay, we have a tank that initially contains 60 gallons of pure water. Brine containing 1 pound of salt per gallon enters the tank at 2 gallons per minute, and the perfectly mixed solution leaves the tank at 3 gallons per minute. Thus, the tank is empty after exactly 1 hour. Now, we have, in terms of the two-part question here, the first part is asking for the amount of salt in the tank after t number of minutes, and the second part is asking for the maximum amount of salt ever in the tank. Okay, so just setting things up here so we can have like a tank initially with 60 gallons of pure water, and we have brine containing 1 pound of salt per gallon is entering the tank at 2 gallons per minute. So we have for the end stream, again, we have the flow rate at 2 gallons per minute. And for the outstream, okay, so we have 3 gallons per minute. Now for what we have in terms of the salt, and we will assign the variable x, whereupon we have x equal to the amount of salt. And just setting things up here. So we have, say we have the in-stream and the outstream. Okay, so for the salt, the concentration is going to be changing. And we can say we have dx over dt is equal to the salt going in minus the salt going out. And for what we have coming in, okay, so the entering flow stream, we have at 2 gallons per minute. And the concentration of salt for the in stream, again, is going to be 1 pound per gallon. Now looking at the consistency of the units. So for what we have going in, you have 2 pounds per minute of salt or sodium chloride. Now for what we have going out, again, for what we have going out, okay, we have the volumetric flow stream. So you have 3 gallons per minute. And we started out initially, okay, with pure water. So there was no salt whatsoever. But as everything is becoming mixed, okay, we have some of the salt is going to be exiting. So we'll say we have X pounds of sodium chloride. And for what we have in terms of the flow rate, okay, now you're going to have 60, and we have 60 plus, okay, your flow rates. Okay, so you have 2 gallons per minute minus 3 gallons per minute times the amount of time, number of gallons. Okay, and let me just reestablish. Okay, so initially the tank has 60 gallons. And for the entering flow stream, you have 2 gallons per minute. Exiting, you have 3 gallons per minute. Times the amount of T, which should be in minutes. And guess what? So we have 60, and 2 minus 3. That's going to be -1 times T. And so collectively, you'll have the number of gallons. Okay, so we have for the rewrite. So again, we have 3 gallons per minute. And you have X pounds of sodium chloride over 60 minus T, number of gallons. Once again, applying the unit cancellation. So we're going to have 3x pounds of salt over 60 minus T minutes. So, and what we have here, so you have dx over dt. You have N, you have 2 pounds per minute of salt. And we have minus 3 all over 60 minus T times X. Here we have a first order linear differential equation. And if I write in standard form, now here we're using X and T as opposed to just Y and X. So this is our first order linear differential equation regarding the amount of salt changing throughout in this tank. And now we have, for what we have had previously with P of X, since we now have the independent variable to be P, we say we have P of T is equal to 3 over 60 minus T. And for the integrating factor, where I had before e to the integral of P of X, I'm now going to have e to the integral of P of T dt so we have e to the integral of 3 over 60 minus T dt. And for what we're going to have in this particular case, all right, is that we're going to have a negative natural logarithmic term. So we have e to what's going to be the negative of 3 times the natural logarithm of 60 minus T. And we have in the rewrite just going from coefficient to exponent. So we have e to the natural logarithm of 60 minus T to the negative 3. And we're going to have 60 minus T to the negative 3. And we can also write this as the reciprocal of the cube of 60 minus T. And with this as our integrating factor, we can multiply the terms in the standard form by this. So you have 1 over the cube of 60 minus T. Going to have dx over dt plus 3 times x all over 60 minus T. And we can say we have 2 all over the cube of 60 minus T. And for what we have on the left, again, you do not have to distribute. Okay, so if I were to distribute, now the terms would end up being taking the derivative in the independent variable, which we have with the letter T, And this will be taking the product of the dependent variable x times the integrating factor. So we'll just say we have x times the reciprocal of the cube of 60 minus t and again we have is equal to 2 over the cube of 60 minus t and removing the parentheses, which can be done upon integrating both sides with respect to t. So we have x all over the cube of 60 minus t is equal to the integral of 2 over 60 minus t to the third dt so at the moment, okay, so we have x all over 60 minus t to the third, and just working with what we have on the right. So just taking what we have here. So we have 2 over 60 minus t quantity to the third dt. I'll just use u substitution since the derivative of 60 minus t goes to -1. So I have u is equal to 60 minus t. And we have that du is going to be equal to negative dt. Whereupon we're going to have the negative of du is equal to dt. So we have the integral of what's going to be 2 all over u, which is to the third. And again, for dt, we have the negative of du and so right now we'll have the negative of 2 times the integral of u to the negative third du. And for the antiderivative, okay, so we have negative 2 times u to the negative 2 over negative 2 followed by the constant. So negative 2's will cancel out. And so we have u to the negative 2 and back substituting. Okay, so we have in essence 1 over the square of 60 minus t followed by the constant. So looking at what we have now, so we have 1 over the square of 60 minus t followed by the constant and multiplying by the cube of 60 minus t. So we have x is equal to 60 minus t plus the constant times the cube of 60 minus t. Now for what we had at the start, again we had pure water. So initially at time 0, there was no salt in the tank. And so we have for t at 0, so we have 60, and 60 minus 0 is 60, so you have 60 plus c times the cube of 60 and for what we're going to have in the layout. Okay, so take away 60, and for C, you're going to have negative 60 over 60 cubed. And so this will be negative 1 over the square of 60, so it'll be minus 1 over 3600. So putting back, okay, for what we have in x, so we have the x is equal to the quantity of 60 minus t. We have minus 1 over 3600 times the cube of the difference between 60 and t. Okay, so that'll be the amount of salt in the tank after t number of minutes. For what we have in the case of the second part, for the maximum amount of salt ever in the tank, and the maximum is going to be whenever you have dx over dt is equal to 0. Okay. So if I take the derivative with respect to the time, so you have dx over dt is equal to 0. And so if I take the derivative of what I have for x, okay, so I have d over dt times all of 60 minus t minus 1 over 3600 times the quantity of 60 minus t to the third. Again, I have is equal to 0. So taking the derivative with respect to t, so 60 minus t, that is going to be negative 1. And we have minus. Again, we have by the power rule, we have 3 times the quantity of 60 minus t squared over 3600. And again, with the chain rule, we have once more taking the derivative with respect to t of the quantity of 60 minus t. Again, we have this equal to 0. And so in this particular layout, we have the derivative with respect to t of 60 minus t. So that will go to negative 1. And so you have negative 1 times negative 3 is a positive 3 over 3600. So you have negative 1 and have plus the square of 60 minus t squared over 1200 is equal to 0. And for what we have in the follow through, okay, so we have 60 minus t squared. Okay, by then you're going to add 1 and multiply by 1200. Okay, so for 60 minus t squared is equal to 1200. Okay, so if I use the square root property of equality, so I have 60 minus t is equal to the square root of 1200. And for the square root of 1200, okay, so that would be about 34.64. And if 60 minus t is equal to 34.64, so we have for t, that is going to be at 25.36 seconds. And looking at what we have here, so for the maximum concentration. Okay, this is going to be at 25.36. So the maximum X is going to be where we have at 25.36 seconds. So you have 60 minus 25.36 minus 1 over 3600 times the quantity of 60 minus 25.36 cubed and for the result here, that's going to be right at 23.09 or very close to 23.09 pounds of salt.